All right, let's look at pivoting tables with tidyr. So this section is all about pivoting data. Pivoting data is the idea of kind of either turning columns into rows, values that are in columns into rows, or values that are in rows into columns. The philosophy of the tidyverse is that these are kind of the rules that make data tidy. Every column is its own variable, every row is its own observation, and every cell is a single value. Seems pretty simple and straightforward, but sometimes you are given data sets where this is not the case. And sometimes you want to try to tidy your data by trying to get them to obey these principles here. So here is an example data frame where it's called storms, and we have one column, storms, a column for wind, a column for pressure, a column for date. And this is tidy. Each variable gets its own column. Each row represents a storm, and it gets its own row. Okay, so here the different columns are different variables. So we have storm, wind speed, air pressure, and date, and that's that. Okay, here is an example of data that is not tidy, or one could argue it is, but in this case, if we think about what our variables are the country, the year, and the number of cases. And in that case, we don't have tidy data because our variable, okay, the variable for country, sure, appears in this column, but then the variable for year are column headings, okay, rather than a column for year. And then the count is kind of spread around across all of these things, okay, so all of these columns, which makes it difficult to deal with. Here's another example. Here, if we think about what our variables are, sure, we have these columns, city, particle size, and amount, okay, but we have New York large, New York small, London large, London small. And I would say the variables are things like the city, the number of large particles, and the number of small particles. And if you think about that, all of the values are in one column. And if you wanted to, you'd have to kind of, if you want the number of large particles, you have to kind of go to every other row. If you want the number of small particles, you have to kind of go to every other row. So it's a little bit difficult to deal with. Okay, these data sets, these toy little data frames are available here on GitHub at these addresses, and so we'll load them up. Okay, so here is our tidy data frame where we have storms and we have wind, pressure, and date. And one nice thing about data when it's tidy is that you can use vectorized operations. So if I wanted to calculate a ratio between pressure and wind speed, that is, I'm going to do the pressure divided by the wind speed, I can just define a new column, okay, storms $ratio, and I can assign the calculation storms $pressure divided by storms $wind speed, or $wind. And so that will just take the pressure, divide by the wind, and it's going to do it for each row. So 1007 divided by 110 is 9.15. 1009 divided by 45 is 22.4. 1005 divided by 65 is 15.5. So on and so forth. We have each row. We calculate the ratio. It's vectorized. It's very quick. It's very kind of handy and nice. All right, let's take a closer look at this table, the cases table. So here we have the country, France, Germany, the United States. Okay, Germany is DE Deutschland. And then the years, okay, are column headings. We have the column 2011, 2012, 2013, and then we have some fictional number of cases of some disease, I guess. Okay, so what we want to do is we want to create a data frame where we have a column for country, a column for year, and a column for the number of cases. Okay, so the variables being country, year, and cases. So pause for a moment and think, if we restructure the data in this way, column for country, column for year, column for the count of cases, how many columns will we have? Right? Well, I think that's going to be 3. But how many rows will we have? Well, we will have 1 row for each observation, and here we have 9 different values. So we're going to end up with 9 rows. And this is what the resulting data will look like. Okay? Here we'll get basically a row for France 2011 with 7,000. In the final data, it's actually arranged by column country first and then year. And then we'll get row for France 2012 with 6,900, a row for France 2013 with 7,000, a row for Germany in 2011 with 5,800, so on and so forth. We're going to have 9 rows. So how do we reshape or pivot the data that's currently in what we would call wide form into long form? Okay, it's long because basically this data frame is longer. So the operation here is pivot longer. Okay, pivot longer. So because we are taking data from wide and we want to make it long. So what we want to do is we want to take the values that are currently spread across the columns 2011 through 2013. So the values are currently in the columns 2011, 2012, 2013. So I'm specifying that by saying go to columns 2011 through : 2013. So we're taking the cases table and we're pivoting it longer. And what it's going to do is it's going to take the column names and put those column names, 2011, 2012, 2013, into its own column. What is that column going to be called? We say the names go to a column titled year. This is the title of our choice. So we're saying that those column headings, 2011, 2012, 2013, get put into the column year. And then the values, these 9 values here, we want them to be kind of pivoted into one long column. Where did those values go? They're going to go into another column, and we give it that column is going to be titled cases. So we say values to cases. And so now we have a table, 9 rows, 3 columns, column for country, column for year, column for the number of cases. So this is just the pivot longer function in detail. It takes 4 arguments. Data is the name of the data frame or tibble that you want to pivot. Columns are the names of the columns that will be pivoted. In this case, we wanted the columns 2011 through 2013. Names to is a character string for what the resulting column of names is going to be called. And values to is a character string that's going to be the name of the column where the values go to. Okay. The names are arbitrary. So, year and cases make sense, but there's no rule that says it has to be year or it has to be cases or anything like that. You can specify, arbitrary names. So here I could say names to when it happened, and now I have a column called when it happened. It just needs to be character string. Here I'm going to take the number of cases and I'm going to call it how many, which is a character string, and that becomes that. Now, it's recommended that you do not put spaces into your column names, because if you do that, you have to surround the column with backticks. Okay, and also recommended you don't start your column names with numbers. Otherwise, they have to start with backticks, which is the case when we had column headings with the names 2011, 2012, and 2013. They're surrounded by backticks because they started with a number. But yeah, the name, this character string is just arbitrary. You can choose whatever you want. Okay, let's ask, what would happen if I only pivot the columns 2012 and 2013? So if I say pivot longer, cases, but then the columns I'm pivoting are only 2012 and 2013. Okay, what will the resulting dimensions be there? Okay, well, if we look at these 2 columns, there's really only 6 values. So the resulting table will have 6 values. Okay, these 2 columns, 2012 and 2013, will get pivoted into 2 columns. One column will be called names, and it will be filled with 2012 and 2013s. And then the other column will basically be the values, which will be the number of cases. And so the names too go to year and cases. What happens to the other columns? Country and 2011 will remain, and they get duplicated. So any column that does not get pivoted just gets duplicated. So basically, France 7,000 gets duplicated, Germany 5,800, Germany 5,800, US 15,000, US 15,000. The other columns 2012 and 2013 get pivoted into the year column, and then the cases get pivoted here. It feels strange to see 2011 being duplicated, 7,000, 7,000, 5,800, 5,800. But that's just what tidyr does. If the column is not pivoted, tidyr isn't going to throw it away. It just duplicates it, right? So when we didn't pivot the country column, those countries got duplicated for every kind of entry here. And so any other column that doesn't get pivoted just gets duplicated. Here it's just the 2011 country, but you could imagine if we had a column for capital, okay, then we would expect Paris to be duplicated, and then Berlin, and then Washington to get duplicated across these rows. So that's what happens. If the columns aren't pivoted, they're duplicated. What happens if I try to pivot all of the columns? If I try to pivot country, so I say let's pivot country all the way through 2013. We're going to try to pivot all 4 things, okay? Then it's going to treat all of these values, not just the number of cases, but also France, Germany, US, as values to be pivoted. So the result is going to be 2 columns, 1 column for the names and 1 column for the values. Now, initially, if you try to do this, you get an error because it says the country values are characters and these are doubles. And so, columns have to all be of the same type, and it says, I can't do that. I can't combine country, which is character, along with, the column 2011 with a double. So it errors out. But we can try to force convert this. And so I'm going to just convert everything into a character. Okay. And then we're going to pivot all of the columns, country all the way through 2013, names to name, values to value. And so now I get a column for names, column for value, and then so we get country, France, 2011, 7,000, 2012, 6,900, country, Germany, and something like that, right? So it looks funny. This is not recommended. We don't really want this, but that's what would happen if you try to pivot too many columns. Okay, let's take a look at the pollution table, which kind of has the opposite problem. Right now, we have a column for the size of the particle and a column for the amount of the particle, but we might want to change this so that we have a column for large particle amount and a column for small particle amount. So how do we do that? Okay, so if we wanted to make this tidy and we wanted to have the column city, large particle amount, and small particle amount, how do we do that? So what we want to do is we want to kind of do the opposite operation. And if we do this, the resulting dimensions is we're going to have 1 column for city, large particle, small particle. If we're going to have 3 columns, how many rows will we have? We will have 1 row for New York, 1 row for London, 1 row for Beijing. So the resulting table will be 3 rows and 3 columns. So this is going to be the result there. Okay. So here we got data in long form, and we want to create data in wide form. So this is going to be called pivot wider. Pivot wider. So we're going to pivot the pollution table, and we're going to say get the names, that is the column names right here, large and small. They're going to come from the size column. So the names are going to come from the size column. The values that get populated into the cells are going to come from the amount column. So we're going to say names from size, values from amount. And this is the resulting table, which is exactly what we wanted. So that's pivot wider. So these are the arguments for pivot wider. Data is the name of the data frame or table. Names from is the name of the column that has the names that will become column headers, and values from is the name of the column that has the values. Pivot wider is case sensitive and spelling sensitive. So what would happen here? Here I changed the city name for the first one to NYC for New York City. Okay, and so what would happen if I say let's pivot this wider? Names are going to come from the size column. Amount is going to come from, the values are going to come from the amount column. Okay, well, how many unique rows will we have? We're going to have a row for Beijing, a row for London. We're going to have a row for New York, and we're also going to have a row for NYC. So we're going to end up with 4 rows. Okay, we'll have 2 columns, a column for large and a column for small. Okay, and what happens is where we don't have a value, an NA gets populated. Okay, so here we have New York City large 23, so the 23 goes here, but we don't have an NYC small, so we get an NA. We have a New York small 14, that gets populated, but we don't have a New York large, so that gets filled with an NA. So if you pivot wider and it can't find it, it populates it, it fills those things with NAs. You can use the argument values fill. So instead of NAs, if you want to fill it with a particular value, you can say fill it with 0 or fill it with 1 or a million or whatever you want, and it will do that as well. Okay. Here, I've fixed the spelling, so we have New York, New York, London, London, Beijing, Beijing, but I've changed large into all caps large. And again, pivot wider is sensitive to spelling differences and case differences. And so if I say take this data frame and pivot wider, names are coming from the size column, values coming from the amount, what is the result? Well, we will have 3 rows. 1 row for New York, 1 row for London, 1 row for Beijing. How many columns will we have? Well, we're going to have a column for each unique value in the size column. So we're going to have a column for all caps large, a column for small, and a column for lowercase large here. So we're going to end up with 3 columns. When we can't find a match, they get filled with NAs. So this is the result. New York with all caps large gets a 23. New York with small gets 14. New York with lowercase large, that's not an original table, so we get an NA. Okay. London, all caps large, doesn't exist in the original table, so that gets filled with an NA. London with small gets filled with a 16. London with lowercase large, 22. Beijing, small and large get filled in. Beijing, all caps large, doesn't exist. That gets filled with an NA. Pivot longer, and pivot wider are inverse operations. So here is our pollution table, and I can pivot this wider, and we get this, right? And I've called this table W. And if I take W and I say, hey, pivot it longer, so that we are going to basically pivot the columns large and small together, then it will do that. So I can take W and I can say pivot it longer, pivot the columns large and small into a column called size and the values into an amount, and we get back this thing. Okay, so this is the result of pivoting longer, and we can see that is equivalent to the original pollution table. Here's the cases table. We pivoted it longer from wide form into long form. Okay, I'm going to call this thing L, and I can take L and I can say pivot it wider if I wanted to. Okay, and so I can say, hey, get the names from the year column, get the values from the count column, and it pivots it wider. And so that reflects back the original table as well. So pivot longer and pivot wider are inverse operations, and depending on your situation, perhaps you actually might want the data in this wider form. Perhaps you want to calculate how much did things change from 2011 to 2012. and you can do 2012 minus 2011 to get a difference column, 2013 minus 2012 to get a difference column or something. And in that case, having the data in wide form could be useful. Okay, so that is using tidyr to pivot your data longer or wider. tidyr has other features as well. I think this is probably one of the most useful features, just being able to master these two functions, pivot longer and pivot wider, I think is highly applicable, and you are likely to encounter some situations at some point in your future where you'll want to pivot your data. Okay, that's it for this video.